Here we go for our second lesson of chapter 2. This is, again, 2.3 and 2.4. So we're going to combine a couple lessons on this one, but I think you'll be okay with it again. So our focus for today is we're going to really think about those drawing conclusions from pictures and givens. And then we're going to focus on some new theorems today that deal with complementary and supplementary angles and proving that we have congruent angles when we have complementary and supplementary angles. So that's kind of what we're going to focus on. So drawing conclusions based on given information in a picture, and then how to prove angles congruent by using some new theorems about complementary and supplementary angles. That's our goal for today. Now, our warm-up for today is actually going to be a little bit different. So this one is actually going to connect directly to the lessons that we've done before. So this first one connects exactly from yesterday, but it just kind of helps us get in that good mindset of drawing conclusions. So what I want you to do, if you haven't done it yet, take a look at the picture, right? And our given for this picture is that angle DEF is complementary to angle HEF. And I would like you to write down as many things as you can that you know for sure based off of that given. Remember, you don't have to tell me things that I can assume from a picture, right? Like EH is a ray. Like, I don't need to know that. I want to know exactly only things that you know for sure based off of the given that angle DEF is complementary to angle HEF. If you haven't done that yet, go ahead and give that a shot right now. Okay, so I think there's more than one thing going on here, right? So angle DEF complementary to angle HEF means that this big angle right here must be a right angle. So hopefully in your list you have that angle DEH or HED, either way, is a right angle. Now, if I know that that's a right angle, then I also know that I have 90-degree angles. So you could also have in that list angle DEH equals 90 degrees. Now, be careful though. Do you know that angle DEF, is congruent to angle HEF? And the answer is no way. Not necessarily congruent, right? That's not part of complementary. It looks like it's split in half exactly, but that's not something that you can conclude based off of that given. We only have our right angles there as our conclusion. Right angle and 90 degrees, as our conclusions. But there was more than one, so making sure that you remember to look for more than one thing, but just be careful that you're not assuming too much. All right, so that was our first warm-up. Here's another warm-up, right? Just doing a little bit more on that conclusions idea. So here's a little bit more complicated of a picture, and this given is that point E is a midpoint of segment AC. That's your given. E is the midpoint of segment AC. So again, write down as many things as you can that you know for sure based off the given, not assumptions from a diagram, but based off of that given. Pause the video and see what you can do. Okay. Now, E is the midpoint of AC. Here's E. Here's segment AC, right? Points on the ends, all right. E is the midpoint of segment AC. So that means that E is splitting segment AC into two congruent parts. So that means that I should have segment AE is congruent to segment EC. I know that for sure because E is a midpoint. Do I know for sure that DE is congruent to EB? Oh, no, I do not. I was not given that E is the midpoint of DB. So be careful that you don't jump to that conclusion. That's not part of the given. But if I have a midpoint, that means that that segment was bisected, right? So you could say that segment DB bisects segment AC. right? It's still splitting AC into two congruent parts, but we could say it with bisect instead of just a midpoint. So there would be two conclusions you could draw based off of that given. So hopefully you're getting more and more confident, comfortable in drawing conclusions based off of a given and a picture and not taking it too far. And guess what? You have just mastered lesson 2.3. That's all that it's about, is just drawing those conclusions. We've been doing that for a long time. We've been doing that a ton of times in our lessons here as we go. So we didn't think that you needed to spend a whole day just on doing the same thing you've been doing all along, and I know you guys are going to do great at it. So that's what we had for 2.3. Let's move on. So let's look at what we've got here. This is a kind of a setup here for 2.4 for some of our new theorems. So here I have three angles. Angle 1, angle 2 over on the right, and then angle A in the middle. Notice that angle A says that it's 70 degrees. And I am given angle 1 is supplementary to angle A. Angle 2 is supplementary to angle A. What conclusions can you make? Go ahead and pause the video and see what you come up with. All right, so hopefully you guys remember that supplementary means that they add up to 180. So I would hope that you would say, okay, well, if angle 1 is supplementary to angle A, right, then angle 1 must be 180 minus 70, which is 110 degrees, right? Okay, so angle 1 equals 110 degrees. They said, well, angle 2 is supplementary to angle A. So angle 2 would be 180 minus 70, which would be 110 degrees, right? Oh, wait, if angle 1 is 110 degrees and angle 2 is 110 degrees, then angle 1 is congruent to angle 2 because they have the same measure. So our conclusion there is that angle 1 is congruent to angle 2. We could put that they equal 110, they equal 110. That would be fine too in your list. But angle 1 is congruent to angle 2. That's a big conclusion. Now my question for you is, what if I didn't give you the 70 degrees? What if I only gave you that angle 1 was supplementary to angle 2, or to angle A, and angle 2 is supplementary to angle A? What if angle A was just x, any number at all? Well, if angle A was just x, I didn't even know what the number would be. Angle 1 would be 180 minus x, right? And angle 2 would be 180 minus x. So even if I don't know what x is, they have the same value, they have the same measure because they're exactly the same thing. So I didn't even have to give you the 70 degrees. If all I give you is that angle 1 is supplementary to angle A, and angle 2 is supplementary to angle A, if they're supplementary to the same angle, then they have to be congruent. That's pretty cool, and that kind of sounds a lot like a theorem. So in fact, that is our very first new theorem. If two angles are supplementary to the same angle, then they are congruent. Pretty cool. Now, the same thing would work with complementary, right? If I gave you pictures of right angles instead of those obtuse angles, and I said, that they were, or I should say acute angles instead of the obtuse angles, said that they were complementary, it would work the same way, right? X, 90 minus x, 90 minus x, it would all work. So if two angles are complementary to the same angle, then they are congruent is another theorem with basically the same proof. So those are two new theorems that we could use now in any proof that comes up. If two angles are supplementary to the same angle, then they're congruent, or if two angles are complementary to the same angle, then they are congruent. Now those are theorems, right? So we have to discuss if they are reversible. So the converse would be if two angles are congruent, then they are supplementary to the same angle. If two angles are congruent, then they are supplementary to the same angle. Well, yeah, I guess if two angles are both 110 degrees, then they're both supplementary to a 70-degree angle, right? It would work. Is it useful? I don't know. Maybe not so much. I probably wouldn't use that quite as much, but it is reversible. So here's maybe one of our first examples of a theorem that is actually reversible. And the same thing would work if I swapped out supplementary with complementary. So both of these two theorems are actually reversible. But you won't use that converse too much. If you'd like to write it down, you can write it down. But the two theorems that we have here, these two are the big ones, and they're going to be the ones you use a lot. All right. Let's see. What's next then? Oh, another one of these situations. All right. So I've got 4 angles this time. Angle G, angle F, angle J, and angle H. I notice that angle G is 23 degrees. It says angle F is supplementary to angle G. Angle H is supplementary to angle J. Angle G is congruent to angle J. Go ahead and write down any of those conclusions that you can come up with based off the picture and the givens. Go ahead. All right, well, I'm actually going to start down here on the bottom given. That's the easy one to mark, right? So angle G is congruent to angle J. That means if angle G is 23 degrees, then angle J is 23 degrees as well. So you could have that written down. Then I see that angle F is supplementary to angle G. So angle F would be 180 minus 23, which would give me 157 degrees. I see that angle H is supplementary to angle J. Angle J was 23, so I have H is 180 minus 23, which would give me 157 degrees. Oh, so now these two have the same measure, so angle F is congruent to angle H. Look at that. Oh. Now, would that have worked if I hadn't given you any numbers? What if I only gave you the givens, but did not give you any of those numbers? No 23. What if I just said X? Well, then J would be X, and F would be 180 minus X, and H would also be 180 minus X, and they're still congruent even if I don't know what the numbers are, right? So if all I'm given is that F is supplementary to G, H is supplementary to J, and G and J are congruent, then I have those two angles are congruent as well. Now, is this the exact same theorem that we just talked about? The answer is no. It's very, very close, but it's not the same. In my last one, I had two angles that were supplementary to the exact same angle. Here I have two angles that are supplementary to two congruent angles. So it's very, very, very close to the same, but not exactly. And with a proof, that makes a difference. You have to be, oh, I'm so sorry. You have to be very picky about your wording, right? Here we go. I apologize about that little mix-up. All right, so this is our second set of theorems. If two angles are supplementary to two congruent angles, then they are congruent. Now do you see why I put in bold the two congruent angles, and in the last one I had put in big, bold, capital letters, same angle, because they're very close to each other, but they are not exactly the same thing. So it also works with complementary as well. If two angles are complementary to two congruent angles, then they are congruent, right? X, 90 minus X, 90 minus X, they're still going to be congruent. So be careful. These are different theorems than the last two, but they're very close to the same thing. Okay, so again, it is a theorem. So the question is, can I do the converse of this? If two angles are congruent, then they are supplementary to two congruent angles. If two angles are the same measure, so 20 and 20, then they're supplementary to two congruent angles, 160 and 160. Yeah, absolutely. That is reversible. Again, is it going to be very useful? I don't know. Probably not. You could probably, find out that those angles are congruent in a better way. But technically, yes, it is reversible. And again, we could swap out our supplementary for complementary. And that would be reversible as well. So both of these are reversible, but the converse might not be very useful. So that's why we're going to focus on the two that I have typed up for you. But if you want to write down the converses, you can do that as well. But these two guys are the biggies, the ones that you're going to use a lot. So now we have technically 4 new theorems, right? But just remember how you're going to keep them separate, right? These last two, in my first situation, I had a total of 3 angles. 2 of those angles being supplementary to the exact same single angle. Those were our first ones, right? Supplementary or complementary to the same angle. Then in the next situation, I had 4 total angles, right? 2 angles that were congruent, supplementary to 2 other angles. So that's where I have 4 total angles, is for the second one where they're supplementary or complementary to 2 congruent angles. So just watch out, how many total angles are we talking about here, right? That's how you know which one of these 2 versions you're going to use. That's the hardest part. So why don't we figure out if we can figure out how to do that. So here's a practice proof for you. Now, if you're in present mode and you're looking at your slides, if you take it out of present mode, there's actually a few more options for steps off to the left, but they just kind of got cut off when they're in present mode. So if you want to do the drag and drop idea here to help you out, just take it out of present mode to do that. But again, the more that you can practice writing these on your own, the better off you're going to be for your homework and for those quizzes and tests as well. So just be ready for that, okay? So if you want to drag and drop, see what you can do. If you want to just write it out, that's not a terrible idea either. So we're given KM is perpendicular to MQ. PQ is perpendicular to MQ. Angle KMR is congruent to angle PQR. And we're going to try and prove angle RMQ is congruent to angle RQM. All right, if you want to pause and take a shot at it, go for it. Okay, I'm going to start just really trying to figure out what's going on in my picture here. On this one, I've got so much going on. Now, when we start getting a more complicated proof, I like to pick a color that I am going to highlight what I'm trying to prove. So I'm going to try and prove angle RMQ, this angle, is congruent to angle RQM, this angle. When I have a lot going on, sometimes it helps just to have your goal highlighted on your picture so you know that you're moving in the right direction, okay? So those are the 2 things that I'm trying to get to. I don't know them yet. That's what I'm trying to prove. Now let's see if I can't figure out what I do know already. So I'm going to start with, my first given was segment KM is perpendicular to segment MQ. KM perpendicular to segment MQ. Oh, I better start writing a little smaller. Okay, that's given. Now, what does that mean if they're perpendicular? Well, if the 2 segments are perpendicular, that means that I have a right angle here, right? I'm just going to write that as my second step. If you like to write all your givens first, awesome, that's fine. Remember, things can go in a different order, and that's okay. But at some point, we probably will need this step. So I'm going to say angle KMQ is a right angle. And that was the definition of perpendicular from yesterday's lesson. So the if part needs to be that it's perpendicular. That was the statement before. If 2 segments are perpendicular, then they form a right angle. All right. My second given, segment PQ is perpendicular to segment MQ. Okay, step 3, PQ perpendicular to segment MQ, and that was another given. Again, if you put all your givens first and then started writing the other things, cool, but I kind of like to understand what my givens tell me, so that's why I kind of do it in this order, but it's totally up to you. It doesn't matter as long as you have these steps in there somewhere. So again, another pair of perpendicular segments means that I have another right angle over here. So step 4, angle PQM is a right angle. And this would be exactly the same thing as step 2, right? If two segments are perpendicular, then they form a right angle. Now you could write that out if you'd like to, or you can write same as 2. That would be perfectly fine as well. It's up to you. Now if you put it in a different order and you had that other right angle step as a different number, remember that it would be same as whatever number that is. So just keep that in mind. But you could rewrite that whatever you had in your if-then form for step 2 again on this step as well. Perfectly fine. All right, what's the next one I have then? My next step is step 5, angle KMR is congruent to angle PQR. Angle KMR is congruent to angle PQR. So these guys right here are congruent. Oh, and I'm trying to prove that those two highlighted angles are congruent. So sometimes, gotta write given is my reason here. I would have forgotten. So sometimes it helps to have that highlighted, right? Because now what's jumping out at me is that I have, let me get a different color here to start writing on it. So I have two right angles, which means that these two angles are complementary. And these two angles are complementary, right? Because they each form a right angle. But I already know that the purple angles are congruent. Oh. So before I can do anything else, I think I got to start saying some complementary angles. So step 6, I have angle KMR is, is complementary to angle RMQ. You see that? These two on the left here, these two over here, whoops. This one and this one are complementary, right? Okay, now my if then, that would be the definition of complementary. My if part is that they formed a right angle, so I got to make sure that my ifs and my thens line up. So if two angles form a right angle, then they are complementary. The if part was that they formed a right angle. That was said in the previous step. Again, if you went with 90 degrees up there, remember that you got to follow that 90-degree thing all the way through. I suggest starting to move towards right angle, but it's up to you. Okay, then I have the two on the right. This guy and this guy are complementary, right? So angle PQR, step 7, angle PQR is complementary to angle RQM. Okay, and again, this would be exactly the same as the last step. So you can rewrite if two angles form a right angle, then they are complementary. That's perfectly fine. Or in my case, I'm going to write same as 6. Again, if you had them in a different order, just change the same as whatever number it happens to be. All right, so I've got my complementary and I've got my complementary. Now, how many angles am I talking about here? 2 complementary angles on the left, 2 complementary angles on the right. That's 4 total angles. So I have if 2 angles are complementary to 2 congruent angles, not the same angle here, right? So last step, step 8, angle RMQ is congruent to angle RQM, my proof statement, if 2 angles are complementary to 2 congruent angles, then they are congruent. Right? Now, if you're still struggling to understand quite how that works on why it happens to be, just do this, right? That it's two congruent angles, not the same angle. Take a look at your complementary steps right above it. KMR is complementary to angle RMQ. PQR is complementary to RQM. I guess those are the ones I'm trying to prove congruent, right? So maybe I go the other way. Angle KMR is complementary to RQM. PQR complementary to RQM. Are those the same exact angle? No, those are two congruent angles. So there's another double check. You can count how many angles you're talking about. If you've got 4, it's got to be the two congruent angles. Or you can look at your complementary steps, and they would have to have the exact same angle listed there if it was going to be the same angle. So double check here to make sure you're using the right one. Because if you wrote, if two angles are complementary to the same angle, then they're congruent, that's not correct. That is, your proof just fell apart because that's not what's showing up in this proof, right? That's not in the picture anywhere. And so then it doesn't make sense. So make sure that your vocabulary matches exactly. I think that was probably the most difficult proof we've done so far. So hopefully you're starting to get the idea. If not, ask those questions, ask your teacher, really understand what's going on here. That was a tricky one, but we did it. All right, and with that, we're going to just wrap it up here. So remember, 2.3 is about drawing conclusions based off of givens in the picture, and we did it a bunch today, and I'm sure you're feeling confident about it. Remember, don't include things that you can assume from the diagram, only things that you can conclude based off of the given, all right? And then when you're proving angles congruent using those complementary and supplementary theorems, be careful. Are they complementary or supplementary to the same angle or to two congruent angles? There's a difference. Okay, so watch out for that. So again, we did do 2 different lessons here, but 2.3 is something we're doing so much that we're not actually going to do homework on it. So your only homework for tonight is from page 79, those 5 problems from 2.4 only. That idea of drawing conclusions is going to come up along the way all the time, so we don't need to do homework on it. But if you'd like some extra practice doing that, if those problems were hard for you today, here's some additional practice listed that you could work on and ask your teacher about if you're feeling like you're struggling, right? And also some more from 2.4 if you feel like you need it.